I want to talk about confidence intervals. This is the situation. We have here our rater, for example, a flight instructor, and he graded the performance of these two pilots, let's say, for example, during an LOE check. The question that we have now is, how good is the performance? Is it average? Is it below average? Is it above average? That's what we want to answer. And in order to do that, we need the standard error. So the first thing that we have to compute is the standard error. And I want to show you how that is done as a first step. We have as a definition the variance, which is the sum of true variance and error variance. And we have the definition of the reliability, which is the ratio of the true variance over the variance. If we bring these two formulas together, we then get the error variance as the product of variance and 1 minus reliability. And in the last step, we take the square root on both sides, which gives the standard error as the product of standard deviation and the square root of 1 minus reliability. And this is what we really are interested in, because we know the reliability and we know the standard deviation. For example, for t values, the standard deviation is 10. And that allows us then to compute the standard error. And we need the standard error to be able to compute the confidence interval. I would like to give you a little bit more of an intuition here. This is the standard deviation, and on the y-axis we have the standard error. Now let's say in this example we have a standard deviation of 6. So we have a standard deviation of 6 in this example. It looks like this. And the question is now, how much of this 6 is the standard error? How big is the standard error? But if we know the reliability, let's say, for example, we have a reliability of 0.9, then we are able to compute the standard error, which is approximately 1.9. So if we know the reliability and if we know the standard deviation, we can see immediately then that determines the standard error. Of course, if we have a lower reliability, for example 0.66, then our standard error is higher, as we can see very clearly here. And now we know the relationship between reliability, standard deviation and standard error. Let's look at these two extreme examples. What if we had a reliability of 0? No reliability at all. We can see immediately here that in this case the standard deviation equals the standard error. We only have error in this case. And the other extreme is that we have a reliability of 1, a perfect reliability, and in this case we see that that there's no error at all. It makes perfect sense. And the next thing that we assume is that the standard error is normally distributed. It looks like this. That means 95% of our errors are within this area, between minus 1.96 times the standard error and plus 1.96 times the standard error. 95% of the errors are in this area. And we have an expected value, of course, of 0. This now allows us to compute the confidence interval. Right? The upper limit of the confidence interval is the observed value plus 1.96 times the standard error, and the lower area of the confidence interval is the observed value minus 1.96 times the standard error. Of course, if we take the confidence interval of 95%. So this is what we have now, and we can see very good in this graphics that a low reliability implies a high standard error, and a high standard error implies a wide confidence interval. This is what we don't like so much. We would like to have a smaller confidence interval. And as a last thing, I would like to mention that this confidence interval means, in other words, that if we measure for our pilots 100 times, for the same pilot 100 times, then in 95 cases we are covering with our confidence interval the true value of the pilot. In 95 cases we are covering the true value, because the true value of the pilot does not change. That's a constant. And in the next video then we will make an example with our pilots.